A signal can be defined as a medium that consists of various frequencies which are essential for transmitting and receiving information. These frequencies serve as the foundation for the communication between 2 points, allowing data to be conveyed accurately and efficiently. Generally, there are two main types of signal: analog and digital signal. Signals undergo several important processes, including analysis, manipulating, and transformation. Two fundamental types of analog modulation techniques are amplitude modulation and frequency modulation. In AM, the amplitude of the carrier wave is varied in proportion to the information signal, while the frequency remains constant. In contrast, FM involves varying the frequency of the carrier wave based on the input signal while keeping the amplitude constant.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Shafiq Alif bin Sheikh. So I will be presenting for question number 2. So based on the question number 2A, we required to prove that the signal is a periodic signal. So for the given signal, Vt equals to A cos 2 pi Fct. We test for periodicity by adding a time period of t equal to 1 over Fc to t. So we get V in column t plus t equals to A cos 2 pi Fc t plus t. So it's equal to, to summarize, it's equal to A cos 2 pi Fct. Since the signal is periodic, so we can say that, we can conclude that the signal is periodic, which means t equal to 1 over Fc. So this is the MATLAB coding and simulation. So based on the MATLAB coding that we created, we got the original cosine signal in time domain as per below waveform. We can see that the cosine signal is generated when we using the coding that we applied in the MATLAB coding. So this is for the question number 2B, where we need to show frequency spectrum of the signal. So in this second part, we need to show the frequency spectrum of the signal. For the cosine function Vt equals to A cos 2 pi Fct, its frequency spectrum consists of two delta located at plus Fc and negative Fc. So in mathematically, we can conclude or express that the formula is Vt is equal to A over 2 delta F negative Fe plus delta F positive Fc. So based on the MATLAB coding that we created, so we got the below waveform showing that the frequency spectrum of cosine signal. So for the last but not least, in question number 2C, we need to demonstrate how the above signal can be transformed to approximate a square wave and show the frequency spectrum. So a square wave can be represented by adding odd harmonics of cosine signals. The approximation is given by v square t, which means sum of the an cos 2 pi n fct. So in this example, we use 5 odd harmonics, which mean f is equal to 5 hertz, 25 hertz, 35 hertz, and 45 hertz. So as we can see here, the amplitude of each harmonic is decreasing as 1 over n. Based on the MATLAB coding that we designed, so the result of the waveform showing like a square-like waveform, which becomes more accurate as more harmonics are added. And in the frequency, based on the frequency spectrum of the square wave approximation, we observe that there is a multiple spike at this harmonics frequency.
Okay, hi everyone. My name is Muhammad Shazrul Bezukifli. So I'm going to explain for the question 7, amplitude modulation. So we have a modulating signal with two frequencies, which are 1 kilohertz, and the second one is 2 kilohertz. We're going to find the resulting modulated signal, then to analyze the frequency spectrum and measure bandwidth, and then calculate the power efficiency. So for the first question, we're going to use this standard AM equation. We have to find the value of K first by calculate using this equation. And then the value of K, we substitute into the we substitute into the AM equation. So this is the final answer. Next, to calculate the frequency spectrum and to measure bandwidth. So we have two sideband, which is 1 kilohertz and 2 kilohertz. Bandwidth is the range between the highest and lower sideband. So the total bandwidth is calculated by this equation, which is 2 times FM. So we get the value of 4 kilohertz as for the answer. Okay, so next, power efficiency measure how much power is in the useful sideband versus the carrier. Here is we calculate by using this formula. So we find the value of PC first. The value of K we take from the previous answer. And next we calculate the value of power sideband. And then we substitute the value into this formula. And the final answer is 64.545 watt. So for the power efficiency, we divide the value of power sideband to the total of power. So the result is only 22.4% of the power carries useful information. So the rest is wasted in the carrier. Next, we move to the MATLAB simulation. So this is the full AM signal in the time domain. So the amplitude change according to the modulating signal. So for the last one is AM signal spectrum. So this show the signal's frequency component after modulation. So the carrier peak is at 1000 kilohertz. So we see the carrier signal with magnitude of 5. Okay, so that's all. Thank you.
My name is Muhammad Nur Azwan bin Selamat. In this video, I will explain the analysis of a frequency modulated signal in question 13. We start with a carrier signal Vc equal 10 cos 2 pi times 10 power of 4 t and a modulating signal Vm equal 2 sin 2 pi times 10 power of 2 t with a modulation index beta equal 2. The FM signal is Vt equal AC cos 2 pi FCt plus beta sin 2 pi FMt. Substituting the values, we get Vt equal 10 cos 2 pi times 10 power of 4t plus 2 sin 2 pi times 10 power of 2t. The spectrum contains sideband at Fc plus minus and Fm, and their amplitudes are scaled by Bessel function J0 beta. Next, we calculate Bessel function J02, J12, J22, and so on, using their series expansion to estimate the sideband amplitudes. For example, J02 approximate 0.222, J12 approximate 0.5764. For transmitted power, we use P total equal AC power of 2 divide 2R. So, 10 power of 2 divide 2 equal 50 watt. P total equal 50 watt. So finally, the bandwidth is calculated using Carlson rule. Bandwidth equal to beta plus 1 Fm. 2 beta plus 1 equal 3, Fm equal 100. So 2 times 3 times 100, bandwidth equal 600 Hz. After that, we comparing my manual FM signal calculation with the MATLAB simulation. From the calculation, I found first transmitted power is 50 watt. Bandwidth using Carlson rules is 600 Hz. Then in MATLAB, I simulated the FM signal, plotted its waveform, and used FFT to show the spectrum. Then result confirm the sideband at Fc plus minus and Fm, just like we show in the manual method. I also plotted Bessel function magnitude to match the paper result and compare it with narrowband FM. Finally, we apply FM demodulation to recover the message signal, showing the full process from theory to simulation. So, thanks for watching.